Okay, this is the first video with Comsol. We're gonna skip back to the beginning of the semester when we were just doing basic mathematics. And I have turned on Comsol, and this is what you'll initially see. I'm going to do a 1D problem, which is what we were doing when we first started. Okay, I click the next arrow. I'm going to look at mathematics. Okay, and I think it's coefficient form PDE. I want to just quick check my notes because I did this last night just to make sure. Coefficient form PDE is correct, is the one I want. So I want to add that. Okay. And we're going to do stationary. That's what we started out with. And this sets up the basic problem with everything that you need to input into here. So I'm going to start with geometry. Okay. And I'm going to do an interval. And the problem that we had to begin with was a d squared u dx squared minus u equals minus x. And that was over the range from 0 to 1. So it's already kind of there for us. And our boundary conditions at those ends were 0 at those ends. So let's go in here and look at our equation. And we will modify that equation to make it our equation. So obviously we don't have any time dependency. So EA and DA are gone. The first term that we have, del squared u, and this is in 1D of course, we have a minus c, but we actually had a positive, so we'll change that to a minus 1. X on this side was minus x. And look at these other coefficients, alpha, beta, and gamma. So if we go back up and we look at these other terms, we will see that alpha, gamma, and beta, we want those to be 0. But we want this a to be minus 1 as well, because it would be minus u. So now we're left with del squared, or d squared u dx squared minus u equals minus x. So we basically got that. Now, right here, they're applying a 0 flux at these boundaries, and we don't really want that. We want to have a Dirichlet boundary condition, which is basically 0. Okay, and if you look, there's the equation, u equals r, okay, and it's 0, so that's perfect. So we're cooking. Okay, and so we've got, basically, we don't have any materials, basically just a differential equation. We need to mesh this, okay, and I'm just going to let it mesh it however it wants. Oops. Did it mesh it? Okay. That's odd. Okay, so I've got overridden, got that, and I've got the Dirichlet boundary conditions in there. I've got my coefficients correctly done. And build all. There it is. Okay, so it's, I must have done something wrong. I have meshed this a little bit finer than I needed to. Actually, let's go back to normal, and we'll do that again. Build all. And it's not quite as fine. Okay? And we can go ahead and compute that now. And you might remember that that was indeed the solution that we got on the first day of class. So I will call that a wrap. And it took me 4.5 minutes to do this.